Good noon, everybody. Myself, Engineer H.S. Taliwar, Assistant Professor in the Department of Electrical Engineering, and today's topic is underground cables. So, first is the introduction. Since the loads having the trends towards growing density, it requires the better appearance, the rugged construction, greater service reliability, and the increased safety. So, the underground cables consist one or more conductors. It is covered with the suitable insulation and it is surrounded by the protecting cover, and interference from the external disturbances like the storms, lightning, ice, trees, these are reduced to achieve the trouble free service. So the cables may be buried directly into the ground or may be installed in ducts buried in the ground, depends upon the type of the cable laying. So for the better appearance, we need the underground cables, and for the better performance. So these are the various types of cables having single core cables, 3-core cables, 4-core cables. And the various types of cables are there. You can see it has various. This is a 3-core cable. This is 4-core cable. These are the single core cables. This is again the 4-core, 3-core cable, and a single core cable. So now we have the cable structure. What kind of structure is there? So starting from the outermost part, we have the hemp braiding. That is the outermost part of the cable that is made of VAR, vulcanized Indian rubber, or maybe some insulating material. Then we have the steel armoring. In the second phase, we have the steel armoring. It is used to protect the cables from the mechanical injuries. Then we have the 2 layers of the Hessian tape. The Hessian tape is there, it has 2 layers. Then we have the jute serving on after the Hessian tape. Then we have the waterproof tape. Lead wire is there. Then again the covering of Hessian tape, and the jute yarn is there. Then the waterproof tape. Then we have the rubber, which is having 3 layers. Then the copper wires. This is the innermost part of the cable. So now we will find out the advantages and the disadvantages of the underground cables. So advantages, the first is the better general appearance is there, as we didn't need the poles and the shabby looks are not there. Then we have the better general appearance. And then the second advantage is it is less liable to damage through the storms or lightning. As we know, whenever there are the storms or lightning, thunder lightning is there, then the overhead lines must be damaged due to the disturbance by the trees or by the wind. So in this underground cables, there should be no damage during the storms or the lightning. Then the third point is the low maintenance cost. The maintenance costs of the underground cables are very low as compared to the overhead lines. Then the less chances of faults. The faults are very rare on the underground cables. Then the small voltage drops. The voltage drops are very small in the underground cables. And the disadvantage, the major drawback is the high installation cost and the introduction of some insulating problems at very high voltages as compared with the equivalent overhead system. So this is the major disadvantage of having higher installation cost and insulating problems at high voltages. Then we have the construction of the cables. On the outermost part we are having the serving, then armoring, bedding, the lead sheath, paper insulation, and the conductors. We will discuss in detail. The core or conductor. So a cable may have one or more than one core. It is depending upon the type of service for which we are intending it. And the conductor could be of aluminium or copper, and it must be standard in order to provide flexibility to the cable. Then we have the insulation. The core is provided with suitable thickness of the insulation depending upon the voltage to be withstood by the cable. So the most commonly used material for the insulation, they are the impregnated paper, varnished cambric, or the rubber mineral compound. Then we have the metallic sheath. The metallic sheath of lead or aluminium, it is provided over the insulation to protect the cable from the moisture, gases, or the other damaging liquids. Then the bedding. So the bedding is provided to protect the metallic sheath from the corrosion and from the mechanical damage due to the armoring. It is a fibrous material like jute or Hessian tape. And then we have the armoring. Its purpose is to protect the cable from the mechanical injuries while we are laying it or during the course of the handling. So it consists one or two layers of the galvanized steel wire or the steel tape. Then in the last we have the serving. So to protect the armoring from the atmospheric conditions, a layer of fibrous material is provided which is known as serving. So the outermost part of the cable. Then we should have the properties of the insulating materials. What should be the properties of the insulating material? First is high resistivity. The resistivity of the insulating material should be high. Then it should have high dielectric strength so that it could withstand the voltages. Then the low thermal coefficient. The thermal coefficient of the material should be low so that it should not be melted. It should not melt at small temperatures. Then the low water absorption should be there. The insulating material should have the properties of low water absorption because water or moisture, it is very harmful for the dielectric strength of the material. Then it should have low permittivity. It should be non-inflammable. It should not catch fire easily. So it should be, we can say it should be non-inflammable. Then the chemical stability, it is very important because the cables are to be buried under the ground. So the chemical stability is very important point. Then the high mechanical strength should be there. The insulating material should have high mechanical strength so that it can withstand the various mechanical parts. So when we handle the cables, then the high viscosity at integration temperature, then the capability to withstand high rupturing voltages. It should have the capability to withstand the high rupturing voltages. Then it should have high tensile strength and plasticity. The tensile strength of the insulating material as well as the plasticity of the insulating material should be high. So this is the properties of the insulating materials are there. It should be able to withstand the moisture. It should be able to withstand the gases, the outer sheath. It should be capable of dealing with the acids, because when we bury the cables under the ground, all these should be there. The acids, moisture and gases should be there. So the insulating material should have the property to withstand all these. Then we have the different insulating materials for the cables. First material we have the rubber. So it can be obtained from the milky sap of the tropical trees or from the oil products. It has the dielectric strength of 30 kV per mm. Then the insulation resistivity of 10 exponential 17 ohm centimeter is there. And the relative permittivity of rubber, it is varying between 2 to 3. And they readily absorb some moisture, soft and liable to damage due to rough handling and ages when exposed to light. And the maximum safe temperature is very low, about 38 degrees centigrades. Then the second insulating material that is used for the cables, that is VIR, known as the vulcanized India rubber. So it can be obtained from mixing the pure rubber with some mineral compounds such as zinc oxide, red lead and sulfur, and it is heated up to 150 degrees centigrade. It has greater mechanical strength, durability and wear resistance properties. So the sulfur, it reacts quickly with copper, so tinned copper conductors are used when we are using VIR. And the VIR, it is suitable for the low and moderate voltage cables. Then the next insulating material, that is the impregnated paper. So this material has suppressed the rubber. It consists of chemically pulped paper, which is impregnated with naphthic and paraffinic materials. Then it has low cost, low capacitance, high dielectric strength and high insulation resistance. And the only disadvantage is the paper is of hygroscopic. For this reason, paper insulation is always provided protective covering. Then the next material, that is varnished cambric. It is a simple cotton cloth which is impregnated and it is coated with the varnish. So the varnish cambric is also hygroscopic, and so it needs some protection as the paper needs. Similarly, the varnish cambric is also needs the protection. And the dielectric strength of the varnish cambric, it is about 4 kV per mm, and permittivity is 2.5 to 3.8. Then the next material, that is PVC, the famous material known for the insulation, that is polyvinyl chloride. So this material has very good dielectric strength, high insulation resistance, and high melting temperatures. But the PVC has not so good mechanical properties as those of the rubber, and it is inert to oxygen and almost inert to many alkalis and acids. Then we have XLPE cables, that is known as the cross-linked polyethylene cables. This is a very good material used for the cables, insulation of the cables, as this material has a temperature range of 250 to 300 degrees centigrade, and this material gives very good insulating properties. It is light in weight, small overall dimensions, low dielectric constant, high mechanical strength, and low water absorption. And these cables permit the conductor temperature of 90 degrees centigrade and 250 centigrade under the short circuit conditions. It can permit the cable temperature, conductor temperature of 90 degrees centigrade under normal conditions and 250 degrees centigrade under the short circuit conditions. And these cables are suitable up to the voltages of 33 kV. So this is the example of cross-linked polyethylene cables. In the upper figure we can see 400 kV XLPE cable with co-regulated aluminium sheath, and in the lower figure we are having 110 kV XLPE cable with laminated sheath. Then we have the classification of the cables. First is the low tension or LT cables. These are used up to the voltages of 1000 volts. Then we have the high tension cables, that is known as HT cables, and they are used up to 11,000 volts. Then the super tension ST cables, and these ranges from 22 kV to 33 kV. Then the extra high tension EHT cables are there, and they are having the ranges from 33 kV to 66 kV. Then extra super voltage cables, ESV cables. They are used beyond 132 kV. So this is the extra high tension cable diagram is there. So we can see the various parts of this cable. The outermost part, that is the PVC jacket, is there. Core binder tape, continuous aluminium armoring is there, fillers are there, ground conductor is there, copper tape sheath is there, and class B compressed copper conductor, extruded conductor sheath, EPR insulation, extruded semiconducting thermosetting insulation shield is there. So this is the extra high tension cable. You can also see the side view of the EHT cable. And this is the LT cable, low tension cable is there, plastic sheath is there, tape, metal shielding, tape, insulation, then again tape, then the conductor. So now we have the 3 core cables. First are the belted cables. So in these cables, the conductors are wrapped with oil impregnated paper, and then the cores are assembled with filler material, and the assembly is enclosed by paper insulating belt, and these can be used for the voltages up to 11 kV, or in some cases it can be used up to 22 kV. Then the high voltages beyond 22 kV, the tangential stresses becomes an important consideration, as the insulation resistance of the paper is small along the layer. So therefore the tangential stresses set up the leakage current along the layer of the paper insulation, and this leakage current causes the local heating, resulting breaking of the insulation at any moment. So this is the 3 core belted cable. Lead sheath is there, and the thickness of the insulation between conductor and sheath. Paper belt is there, and there is a thickness of insulation between the conductors. Then in the 3 core cables category, we are having the screened cables. Now these can be used up to 33 kV, but in certain cases these can be extended up to 66 kV. So they are mainly of 2 types. First is H type, then SL type cables. So H type cables, it is designed by H house standard, and each core is insulated by a layer of impregnated paper, and the insulation on each core is covered with the metallic screen, which is usually of perforated aluminum foil, and the cores are laid in such a way that the metallic screen make contact with one another, The basic advantage of H type is that the perforation in the metallic screen assists in the complete impregnation of the cable with the compound, and thus the possibility of air pockets or voids in the dielectric is eliminated. The metallic screen increases the heat dissipation power of the cable. So we can see this is the 3-core cable of H type. We can see the various parts. This is the outermost part, the serving is there, then the armoring is there, bedding, lead sheath is there, conducting belt is there, this is the conducting belt, and this is the paper insulation, and this is the metallic screen. So the paper insulation is there out of all the 3 conductors, then it is kept in the conducting belt, then the lead sheath is there, bedding, armoring and serving. So this is the diagram of the H type cable, H type 3-core cable. Then we have 3-core cables SL type, that is known as separate lead type. So in this type of cables, the each core insulation is covered by its own lead sheath. It has 2 main advantages. First, the separate sheath minimizes the possibility of core to core breakdown. And secondly, the bending of cables becomes easy due to the elimination of overall sheath. And the disadvantage that the lead sheaths of separate lead is much thinner as compared to H type cables. Therefore, for greater care is required during the manufacturing of this SL type cables. As we can see the difference between SL type and H type. In the innermost part, it is having the lead covering is there instead of the paper covering, the lead covering, or we can say each is provided with the sheath. Lead covering is there, then this is the conductor lead covering is there, armoring, serving and the cotton tape. So in the next category we are having the 3-core cables, that is a pressurized type cables. So in these cables the pressure is maintained above the atmosphere level either by the oil or by the gas. So the gas pressure cables, they are used up to 275 kilovolts, and the oil filled cables are used up to 500 kilovolts. So we can see the diagrams of the 3-core cable having the gas pressure. This is the conductor. In the central part it is hollow and the gas pressure is there. This is the gas duct is there. We can see the serving, armoring, bedding, paper insulation, lead sheath, and these are the conductors. But from the central part it is having the duct is there in which the gas is maintained at some pressure. as we can also see in this diagram. This is the conductor and these are the various outer assemblies, but it is hollowed from the center, which is called the gas duct. Then we have the oil filled cables. Instead of gas, we are filling